In the last video, we practiced using the fundamental theorem of calculus by finding the definite integral of a straight line, which was nice because we could use the fundamental theorem of calculus to verify that the area that we got actually matched the geometric area that we could calculate by finding the derivative of, finding the area of the trapezoid. What we're going to do now is we're going to do the second problem on the bottom of page 503. All right, and so I've filled this in already, the first part, that this is going to be a trapezoid again, and I've calculated the area of the trapezoid as 12, just like we did in the last problem. So this is the same function we used before, so it's going to have the same antiderivative. So it's going to be negative x squared plus 3x. I'm not going to bother with the constant term because we never do. I just wanted to do it that one time to demonstrate to you that that it shouldn't matter which antiderivative you use. All right, and so this is equal to negative 5 squared plus 3 times 5 minus negative 2 squared plus 3 times 2. Okay, and so negative 5 squared is negative 25. Notice that we're doing the square and then the negative. Remember that negative x squared is different from negative x squared. So this is always going to be a positive number, whether x is positive or negative. This is always going to be a negative number because x squared is positive, and then taking the negative of that is going to make it a negative number. Be careful when it comes to doing that. If you've got a calculator that does the order of operations and you are careful with your parentheses, you'll be okay. All right, negative 25 plus 15 is negative 10, minus negative 4 plus 6 is 2. So negative 10 minus 2, we have an area of negative 12 this time, which doesn't match our area of 12. Can you think, looking at this diagram, why we would have a different result from this time up here? And what do you think our convention would be for what negative integrals indicate? I'm not sure how often I've mentioned it before and whether it came up in one of these videos or not. I think it did, but it was really a notion I made in passing, that when we're calculating the area between a curve and the x-axis, we're going to count areas below the curve as negative areas. So this is going to indicate an area of negative 12, and this area is all above the x-axis, so that's going to be an area of positive 12, even though these two trapezoids are congruent to each other. Okay, so we've got that important distinction that areas below the x-axis are going to have a negative area. So other than that, that would explain why the area of the trapezoid is 12 and the definite integral is negative 12. All right, we will do the first example, I think. We'll do one of the examples on the next page, and I'll leave the other two for you to practice with and see how things might get even a little bit more complicated if we're taking an integral that has some positive and some negative parts of it.